My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 467. In this lecture, we will try to understand clustering. We will understand a completely new type of problems that we solve in machine learning is called clustering problems. Before we understand clustering, let's quickly recap what is classification and what is regression, because we already learned what is classification and what is regression are. We will try to connect how classification and regression are connected to clustering. Given a data set capital T equal to xi comma yi. What is my xi? Given data point. Yi is class label or regression value for yi, isn't it? Your yi belongs to 0 comma 1, that is two classification. 0 is one label and 1 is another label, isn't it? Because you are trying to find a function where given x, you are trying to find y equal to f of x, isn't it? In the case of classification, your yi belongs to 0 comma 1, two classification. In the case of regression, your yi belongs to r. That is the basic difference. In the case of classification, your yi belongs to 0 comma 1. This is binary classification. If it is your regression, your yi belongs to r. But in the case of clustering, what happens is you are just given bunch of data points. In the case of clustering, you are just given a bunch of data points. Capital D equal to, what is my capital D? Equal to xi. There are no, in the case of clustering, there are no yi's. In the case of classification and regression, the task is given an x. You want to predict class label or regressible value. The whole task in classification and regression is first to find this function f. This function f, and either through logistic regression or trees or random forest, multiple techniques. All we are trying to find function f which maps, you have to find function f which maps point x to its class label or regressible value. In the case of clustering, you do not have, in the case of clustering, just you have data point. You do not have any more yi's. You are just given x's, and your task here, task in the case of clustering is to group or to cluster. What is the task here? In the case of the task here, to group or cluster, basically means to group. In English, what is your task? To group or cluster similar data points. I am going to put similar, I am going to put similar in double quotes, isn't it? Because big question here is, what is the similar means? We will come to this in a while geometrically. Suppose you have bunch of points like this. Suppose this is your, what is your feature 1? Let me assume this is my, just a minute. Yes, this is your feature 1. Let me say this is your feature 1 and this is your feature 2. No yi's, isn't it? Just given capital D equal to, xi, bunch of points. Now, if you have data like this, the task of clustering is to group similar data points. What similar means? We will come to that in a while. For now, here geometrically speaking, imagine if I have f1, feature f1 and feature if I have feature f1 and I have feature f2. Feature f1, let me assume this is my feature f1, this is my feature f2, isn't it? Like this, if I say group similar points given this visual data, even a 5-year-old kid would say all these points, a 5-year-old kid may say all these points, even 5-year-old kid would say all these points can be grouped into one set because they are close to each other, isn't it? All these points are grouped into one cluster. All these points are grouped into another set. A 5-year-old kid would say there are 3 groups of points or there are 3 clusters here. You can use the word group or cluster interchangeably. So a 5-year-old kid, if you show him this data and group similar points, if you say this is cluster, let me say this is cluster C1. Yes, this is, what is this? This is cluster C1, this is cluster C2, this is cluster C3, isn't it? So you would group them in this 5-year-old kid has definition of similarity is points are close together. Points are close together. All these points which are close together are in one cluster, isn't it? This just see, in C1 all the points are close together, isn't it? And farther away from these points are farther away from other points. So the 2 things that is looking for, first one is points in a cluster are close together, points in different clusters are far away from other, isn't it? For example, if you take this, if you take this point, if you take this particular point, for example, if you take this point and if you take this point, isn't it? They are far away. These 2 points are far away, isn't it? Far away from each other. They put in different clusters. That's what a 5-year-old kid will see visually. Group these things. What is the similar means? Similar is again very problem specific. It's very to task specific. And how do you measure this similarity? We will revisit these points through this chapter. We will revisit these problems through this chapter of clustering. From mathematical standpoint, all your given xi's, capital D equal to xi, there are no yi's. How now the big question that we will answer in future videos. What is question? How do you measure how well your algorithm perform? Remember in the case of classification and regression, we had bunch of metrics. We have performance metric. We had bunch of performance metrics like AUC, precision, recall, R-squared metric. We have bunch of metrics in the case of classification and regression, isn't it? All of these metrics needs yi. All these metrics needs yi, but you don't have any yi in the case of clustering. So how do you measure it? We will see those in one of the videos later in this chapter. But the most important task away for now is that task of clustering. You are given a data set capital D equal to, what is my capital D? My capital D equal to just a data point, isn't it? Capital D equal to just, let me say, xi, isn't it? Where there are no yi's, your task is to group, cluster similar data points visually speaking. If these are your points, each of, if the, for example, let me say, yes, if these are your points, each of, just let me consider this. Yes, if these are your points, isn't it? Each of these crosses are your points, isn't it? This crosses is your point, this cross is also your points. You would group these points as one cluster, isn't it? Your points as one cluster, these points is another cluster, these points is another cluster. That's what we were saying. Within a cluster are because the points within a cluster are close to each other. Just see, within a cluster, points which are within a cluster are close to each other, isn't it? Points in two different clusters are farther away. If there are these 2 points are farther away, isn't it? Points in different clusters are farther away. This is what you would use as a key logic for measuring how good a cluster later on. We learn 3 major techniques. Three major techniques for clustering, isn't it? We learn something called k-means and some variations of k-means. We learn like k-means plus k-medoid, etc. But k-means is the base algorithm which we will learn in full detail. We would also learn something called hierarchical clustering. We will also learn something called hierarchical clustering, and we will also learn something called DB-scan algorithm, isn't it? There is some algorithm known as which algorithm? DB-scan algorithm. Each of these are different types of algorithms for clustering. Again, clustering just like classification, very broad area, and these are the 3 most used and most applied techniques, and hence we are taking them up. There are also special clustering algorithms designed for specific domains. So there are algorithms for clustering images which only works for clustering images and not for everything else. So in this case, we will primarily focus on general purpose clustering algorithms to understand clustering algorithms, how it works, where it works. It is very interesting journey because we have learned classification regression. Now we are going to learn clustering. Just go through these concepts. If you have any difficulty, please keep a comment. Thank you very much.